Hello students, today we will solve the rest of the sums of exercise 6.1. Now question number 4. A figure is given and in this figure this angle AOC is Y, BOC is X, AOD is Z and DOB is W, and according to question it is given that X plus Y is equal to W plus Z. That is X plus Y is equal to this W plus Z. Now I have to show that AOB, that is this AB, is a straight line. Now see the proof part. So it's given X plus Y equal to W plus Z, and we have to prove that this to prove AOB is a line. So from figure we have, see in this figure X, if we add all this angle X plus Y plus Z plus W, then what happens? We get the complete angle. If we add X plus Y plus Z plus W, we get the complete circle or complete angle, and its complete angle is 360 degree, 360. That is, from the figure we have X plus Y plus Z plus W. If we add all this, we get 360 degree. Now, from here, X plus Y plus, in place of Z plus W or W plus Z is same, we can put X plus Y again. So in place of this Z plus W, we can put X plus Y again, is equal to 360 degree. You can write, since X plus Y equal to Z plus W or W plus Z is same. Now this implies X plus Y plus X plus Y, that is twice X plus twice Y. So you can write twice of X plus Y. That is X plus Y plus X plus Y, suppose twice X plus Y is equal to 360 degree. Now X plus Y is equal to, that is 2 is multiplied with X plus Y. If we take 2 to right hand side, it becomes 360 degree by 2. So if we cancel 360 by 2, we get 180 degree. That is X plus Y is equal to 180 degree. That is, we get this X plus Y is equal to 180 degree. That means X and Y are linear pair. Therefore, X and Y are linear pair, and if X plus Y are linear pair, then the non-common sides of this adjacent angle makes a line. Therefore, AOB is a straight line. AOB is a straight line. So this is the proof. So our next question is question number 5. A figure is given. So first we have to write what is given in this question. So given POQ is a line, that is POQ is a line, and a ray OR is perpendicular to the line PQ, that is OR. OR is a line perpendicular, that is this symbol means perpendicular, that is this angle is 90 degree and perpendicular to line PQ, and OS is another ray lying between the rays OP and OR. That is, we have OS is another ray which is lying between this ray OR and OP. Now we have to show that the angle ROS, this angle, this is the angle ROS. This angle is half of the angle QOS, that is QOS is this QOS this angle minus POS, that is minus this. So we have to say that this angle is equal to half of this angle minus this angle. That is, if we take this 2 to left side, that is twice of ROS, that is twice of ROS is equal to this angle minus this angle. We have to prove it. So how you prove? See. So we have to, so QoS minus POS. So this is the QoS. So first we'll write from figure, we have from this figure angle QoS is equal to this QoS, this angle is equal to, we have two angles combined here, angle QOR plus ROS, that is QoS can be written as angle QOR plus angle ROS. That is, if we add these two angles, we get a complete angle. Now this QOR, that is OR is perpendicular to PQ, that means this angle is equal to 90 degree. So you can write, in place of QOR, you can write 90 degree plus ROS and give this as number 1. Next, after QoS, we need to find POS. So again, angle POS is equal to, POS means this angle, is equal to, we can write this whole angle, from this whole angle, if we subtract this part, from this whole angle, see, if we subtract this part, we get this, that is POS. So equal to angle POR, that is POR, that is the whole angle, minus angle ROS. And similarly, you can write angle POS is equal to POR, that is OR is perpendicular to PQ, so is equal to 90 degree minus angle ROS. Give this as number 2. Now in this part, QoS minus POS, that is QoS is here, POS is here, that is we have to subtract equation number 2 from 1. That is, if you subtract 2 from 1, we get QoS minus POS. Now 1 minus 2 implies, that is subtracting equation number 2 from 1, angle QoS minus angle POS. That is, when you subtract one equation from another, we have to subtract the left hand side from the left hand side and right hand side from right hand side. So is equal to, that is QoS minus POS is equal to, right hand side is here 90 degree plus ROS minus right hand side of this, it is minus 90 degree, and minus becomes plus angle ROS. Now this 90 and minus 90 is considered, so we get angle QoS minus angle POS is equal to ROS plus ROS, we get twice of angle ROS. Now if we take these two to left side, we get half of QoS minus angle POS is equal to angle ROS. That is, we get angle ROS is equal to half of angle QOS minus angle QS. So hence root is the, or you can write here ROS equal to, this implies ROS is equal to this half of this in the right hand side. Okay. So next is the last question of this exercise, question number 6. So given XYZ is angle XYZ equal to 64 degree and XY is produced to point P. Now we have to draw the figure using the given information. So first we have to draw an angle XYZ equal to 64 degree using a protractor. So we will draw here using my scale. Suppose this is X, Y and Z. This is an angle XYZ is given is equal to 64 degree. It is 64 degree and XY is produced to point P. XY means this line XY. X, if in a question YX is produced, then we have to produce this YX this in this direction, in the direction of X. But XY, that is, we have to produce it in the direction of Y. That is like this. It is XY is produced to a point P now. So this is the figure. And then given that if a ray YQ bisect angle ZYP, it's ZYP, this angle is bisect. Bisect means equally divides into two parts. So YQ, that is from Y, there is a ray here. It's Q, YQ, this YQ bisect the angle ZYP. That means this angle and this angle are equal. Bisect means these two angles are equal, equally divides. Next we have to find XYQ, that is XYQ. We have to find this angle. We have to find this angle XYQ and reflex of QYP. It is reflex of this angle. That means the opposite part of this angle. That is, if we add 180 with this XYQ, we get a reflex of QYP. Now see the proof. So proof. So first we have to show that these two angles are equal, since YQ bisects angle ZYP. It's given YQ bisects angle ZYP. Therefore, angle ZYQ, that is ZYQ, this angle is equal to angle QYP. Angle QYP. Suppose this is as number 1. So from figure we have, what we have? So XY is produced to P, that means XYP is a straight line, and this angle, if we add this triangle, that is XYZ plus ZYQ plus QYP, we get 180 degree. So we have angle XYZ plus xyz plus zyq plus qyp is equal to 180. Or you can write xyz plus zyp also. Then in case of zyp, you can write twice of zyq because they are equal. Now, so you can use any method. So angle xyz plus zyq plus in place of qyp we can write again zyp. Angle zyq is equal to 180. Here write using 1. So we use this qyp equal to zyp. Now xyz equal to 64 degree plus this two are same, twice of angle zyq is equal to 180 degree. Next twice of angle zyq is equal to 180 degree minus 64 degree, that is angle zyq is equal to 180 minus 64, 116 degree by 2. So you get 8 degree. That is implies angle zyq is equal to 58 degree. Now we need to find xyq. Therefore angle xyq is equal to angle xyz plus angle zyq is equal to 64 plus 58 degree is equal to, so 64 plus 58 is equal to 122 degree. So this is the answer. So next, reflex QYP is equal to, that is QYP is this angle is QYP. Reflex of this means the opposite part. That is we can write 180 plus, this part is 180 plus this angle XYQ. It is 180 plus XYQ is equal to 122. So is equal to 302 degree. Or you can write a reflex of QIP is equal to, or you can write like 360 minus this QIP, angle QYP, or 360 minus, in case of QYP you can write ZYQ, same angle ZYQ, it's same. So equal to 360 minus ZYQ is equal to 58 degree. 58 degree, it is we find already. Now 360 minus 58, 302 degree. So you can proceed this way also. We get the same result. Okay. So our next topic is parallel lines and a transversal. So first recall what is a transversal. So transversal is a line which intersect two or more lines at a distinct points. That means suppose we have two lines, this line and this is another line, or there may be more lines, two or more lines, that is there may be 3 lines, 4 lines, etc. If a line intersect these 2 points, these two straight line at 2 distinct points, then this line, suppose first line is AB, second line is CD, and here this EF. That is EF intersect AB and CD at 2 points, they are P and Q respectively. That is P and Q are 2 distinct points, means 2 different points. Then this line EF is called transversal. Now see, when a transversal intersect the lines, then at each point, suppose at point P, we get 4 angles. Suppose we name it, suppose the name the angle 1, this is 2, this is 3, this is 4, and similarly at Q also we get 4 angles. Suppose the angle is 5, 6, 7 and 8. Now recall the names of this angle. This angle 1, angle 2, angle 7 and angle 8 are outside this line AB and CD. So they are called exterior angle. Exterior angles. And this angle 3, 4, 5, 6 are inside this line. That is inside this line AB and CD. So they are called interior angles. Interior angles. So first we get 2 types of angles. Here 1, 2, 7 and 8. 1, 2, 7, 8 are called exterior, and 3, 4, 5, 6. These 4 angles are called what? Interior angles. Now see. Angle 1 and angle 5. This angle 1 and angle 5 are same side of this transversal and same side on the straight line. That is this 1 and angle 5 are called corresponding angle. So we have corresponding angles here. Corresponding angles, what? Angle 1 and angle 5. You can write angle 1 and angle 5. Similarly, angle 2 and angle 6 are on the same side of the transversal and on the same side of the lines. That means in upward direction. So 2 and 6 are another pair of corresponding angles. Similarly, angle 3 and angle 7 are on the same side, that is in the down sides of this AB and CD, and on the left side of EF. That is angle 3 and angle 7 are also called corresponding angles. Next, similarly 4 and 8, this 4 and 8. 4 and 8 are also called corresponding angles. That is, when 2 lines are intersected by a transversal, then we get 4 pairs of corresponding angles. Similarly, we get alternate interior angle. alternate interior angle. That is this angle 4 and angle 6. Angle 4 and angle 6 are inside this interior angle, and they are called in the opposite side of this transversal. So 4 and 6 are called alternate interior angle. Similarly, 3 and 5 are called alternate interior angle. Similarly, alternate exterior angles are also there. Alternate exterior angle, angle 1 and angle 7, they are exterior angle but in opposite side. So angle 1 and angle 7 is pair of alternate exterior angle, and 2 and 8 are called this alternate exterior angle, and this 4 and 5 are the interior angles on the same side of the transversal, and similarly 3 and 6 interior angles on the same side of the transversal. So you get four pairs of angles here. It is 4 types of pair. But in our discussion in the later part, so alternate interior angle can be termed as only alternate angle. That is, when we call, suppose some angle A and angle B are alternate angle, that means remember it, alternate interior angle. So we will not write this all interior word. And next, for parallel lines, what is the property of this corresponding angle and alternate angles? We will discuss it in the next class. Okay? Thank you.